You're watching Vue Mastery's Vue3 Reactivity course. And why should you care about this course? Well, you're going to be learning about Vue3 design patterns, how it's designed under the hood, which may help you create more powerful applications. You'll also get improved debugging skills because the next time you do a stack trace through your code, maybe something's going wrong, you'll recognize some of the underlying functions in Vue3. Also, the way that Vue3 is built is that reactivity is a separate module. So you can use this code in new and creative ways that you couldn't before with Vue 2. And lastly, if you want to contribute to Vue, you'll now understand the Vue 3 source code a little better. The way Vue 3 handles reactivity is completely different than Vue 2. So if you've seen my reactivity lessons in the Advanced Components course, this is all new content. You're going to want to stay tuned. Also, I need to make sure that you are familiar with the basics of Vue, as well as basic JavaScript. Now that we got that out of the way, let's jump into the course. And it starts by taking a look at a simple Vue app and a simple template. If we load up this component and then our price changes, Vue somehow knows to go and update the template here and our computed property, which updates the template here. So the question is, how does Vue know how to update all the things? And specifically, Vue's reactivity, because this isn't how JavaScript usually works. If we have price and quantity, and we have a total which multiplies them together, and we print out the total, and then we update the price, total is still 10. It doesn't get updated, there's no reactivity here. In the first two lessons of this course, we're going to build a reactivity engine from scratch. This is useful because we'll build it in the same exact way that Vue 3 does reactivity. We'll solve this problem step by step. And first, we need to ask, how can we save the total calculation so we can run it again when price or quantity updates? So let's think about this for a second. This piece of code, we want to be able to save it in some sort of storage. Then we need to run it. And then later on, we want to run this stored code again. And we might have more than one piece of stored functionality. So let's write this out again, and this time set our total calculation in an anonymous function and store it inside of effect. This is the code we want to save. Then we'll call track when we want to save the code we have inside of effect. We'll run this effect to calculate the total for the first time. And then sometime later on, we'll call trigger, which will run all the code that I've saved inside of our storage. By the way, the names I'm using here for effect, track, and trigger are the same names you'll see in the Vue3 reactivity source code. Let's go ahead and use an arrow function here to shorten our code. To store our effects, we'll use a dep variable, which stands for dependency. And it's a new set. To track our dependencies, we will add the effects to the set. The reason we're using a set here is because a set does not allow duplicate values. So if we try to add the same effect, well, it won't add it twice. And then our trigger function will go through each of the effects in our storage and run them. So if we run this code, our total is currently 10. If we change our quantity, we can then see that our total is still 10, but then once we run trigger, it reruns our total calculation, and now our total is 15. Often our objects will have multiple properties, and they each need their own dep, or set of effects. So how can we store or have a dep for each of our properties? Here you can see we've encapsulated price and quantity into a product object. Each of these needs its own dep. A dep is basically a dependency, which is a set of effects that should get rerun when values change. As we saw, it's of type set. Each value in the set is simply an effect that we need to rerun, like our anonymous function, calculating total. To store these deps in a way to find them later, we're going to create a deps map. It's a map where we store the dependency object for each property. A map has a set of keys and values. We'll use our object's property name as the key, such as quantity or price. Our values in this case will each be a dep. Let's code this up, starting with our depths map. Our track function is first going to get the dep for this particular property. The key here will either be price or quantity. If it doesn't have a dep yet, let's go ahead and create one and store it in our map under the key. And then we'll add this effect. And remember, since it's a set, it won't add the effect again if it already exists. Our trigger function will first get the dep for this key. If it exists, it will go through each effect and run them. Now back to our original code with our product, total, and our effect. Here we're going to call track quantity, which will store the effect, and then we'll run the effect. If we run this in our console, our total is now 10. We can set product quantity to 3. In order to run total again, we run trigger and specify the property, which is quantity. The effect was run and the total is now 15. Great. Great! So now we have a way to track dependencies for different properties. But what if we have multiple reactive objects, such as a user object? So far we have a deps map, where we store the dependency object for each property, and each of those properties has its own dep with effects to rerun. We need some other object over here, maybe a map, where the keys somehow reference our reactive objects, such as product or user. This is where we'd store the dependencies associated with each reactive object's properties. In Vue 3, it's called a target map, and it's of type weak map. A weak map is simply a map where the keys are objects. So let me show you what I mean. If we create a weak map, we can then set the key equal to our product and our value maybe just a string called example code to test. To get that value, we would call get and again send in an object. And it would print out example code to test. This is just an example to show you how weak maps work. Do you get it? At this point I was wondering, why does Vue 3 call this target map? And don't worry, it'll be clear in the next lesson. So now let's code this up, starting with our target map, which is for storing the dependencies for each reactive object. Then in our track method, we'll first get the current depths map for this target, which in our case will likely be product. If it doesn't exist yet, we'll create a new depths map for this object. We'll then get the dependency object for this property, which might be quantity. If it doesn't exist, let's go ahead and create it as a new set. And then we'll add the effect to the dependency. Then in the trigger function, we'll check to see if this object has any properties that have dependencies. If no, we can just return from the function immediately. Otherwise, we'll check if this property has a dependency, and if it does, we'll go through each effect and run it. There's more to our code. Remember, we have our product, our total, and effect. This time when we call track, we'll send in the product and the quantity. If we execute this code, our total is currently 10. We'll change the quantity to 3. Our total is still 10 because we need to trigger sending in the product and the quantity property. And now our total is updated to 15 because it ran our effect. Let's look back at our diagram one more time. Our target map is where we store the dependencies associated with each reactive object's properties. Depths map is where we store the dependencies for each property. And dep is a dependency which is a set of effects that should get rerun when values change. So we have a way of storing our different effects, but we don't have a way of rerunning our effects automatically. That's the second big piece coming up in the next lesson. Welcome back. In this lesson, we're going to be finishing our reactivity engine, coding it up just like Vue 3 does reactivity. In our last lesson, we ended up with this code, where we're still calling track and trigger to record our effects and to play back our effects. We want our reactivity engine to call track and trigger automatically. Basically, when running an effect, if product properties are accessed or get, that's when we want to call track to save that effect. And if product properties are changed or set, then we want to call trigger to run those saved effects. So the question becomes, how do we intercept those get and set methods? Well, in Vue 2, we used ES5 object define property to intercept get and set. With Vue 3, we're going to be using ES6 reflect and ES6 proxy. Because we can. The reason we can use ES6 with Vue 3 is that Vue 3 out of the box does not support Internet Explorer. So we can use, modern JavaScript stuff. Tell your grandmother to download Chrome. You know who you are. Let's break down reflect and proxy so everybody knows how they work. Here's our product, and there are 3 ways to print out a property of an object. First, we can use typical dot notation. We can also use bracket notation, which you'll see me using later. And we can use ES6 reflect, like you see here. All 3 are valid, but reflect has a superpower that I'll show you in a minute after we understand proxy. A proxy is a placeholder for another object, which by default delegates to that object. So if I create a proxied product and declare a proxy like so, and then I call proxied product.quantity, this is going to first call the proxy, which calls product, back to proxy, return that to the console log, and it's going to print out 2. It simply delegates to the object. You see that second parameter in proxy? That's called a handler. And in that handler, you can send in a trap. A trap allows us to intercept fundamental operations like a property lookup, or enumeration, or function invocation. So in our case, when we call get on our proxied product, we want to modify the behavior. For now, we'll simply log out that it was called and return a string with not the value. So when we run proxied product.quantity, it's going to call our proxied product, print out get was called, return not the value, which then gets printed out to the console. We've now made our get method completely useless. So let's actually return the value now. We'll declare get with 2 parameters, which I'll explain in a second. Then we'll log out get was called with key equals key, and we'll return the value of the key property using bracket notation. So when our console log gets called, it calls our proxy product with get target. The target in this case, since we send in product, becomes the value of target. Our key is quantity because we want to get quantity. Our code then prints get was called with key equals quantity, and it returns the value of that property. Here is where reflect comes in. Using proxy with reflect, we now have an additional parameter called receiver, which will pass into our reflect call, which ensures the proper value of this is used when our object has inherited values or functions from another object. This will avoid some reactivity caveats we used to have in Vue 2. And this will print out the same as before. Our proxy also needs to intercept our set method. Let's do that now. Our set receives target, key, value, and receiver. We'll print out that set was called with our key and value. And then we'll call reflect.set with target, key, value, and receiver. We can test this by setting our quantity to a different value. In the console, we would see set was called with key, quantity, and value 4. Get was called with key equals quantity, and then it would print out 4 to the console. Remember when I said that second parameter of proxy is called handler? Let's encapsulate this code a little more like we would see it inside the Vue 3 source code. We'll create a function called reactive, which should look familiar if you've used the composition API. Then we'll wrap our get and set method inside a handler constant. And finally, we'll create a new proxy object, sending in our target and our handler. Now, when we declare our product, we'll simply send our object into the reactive function, which returns a proxy object which we use as if it's the original object. Then we'll change the product quantity and print it out to the console. we get what we'd expect when we execute this code. All right, with this new knowledge, let's go back to our original code. Remember, we have our effect, we call track, and we call trigger. And we needed some way to listen for GET request in order to call track, and listen for SET requests to call trigger. Let's set those functions aside and figure out where they would go inside of our reactive function. Inside our GET trap, we'll use reflect to get the value of our property, and that's where we want to track the effect that's running. So inside GET, the product will be target, and the property will be the key that gets sent in. Let's go ahead and move that code into a reactive function. Then we'll return the result. Inside of our set method, we'll get the current value of our target, and we'll set it equal to the new value, calling reflect.set, which returns a Boolean indicating if the set was successful. We'll store this in result. And if the set was successful and our old value isn't equal to our new value, that's where we want to call trigger. The product here is the target, the property is the key, so let's go ahead and move this into our reactive function. Then we'll simply return the result, and finally create a proxy for our target with the handler. That's our code. And down below we have our original code, and it looks like here we're still calling track and trigger, which we don't need anymore, so let's go ahead and remove this code. Let's walk through this code visually, because it's important to me that you really understand what's going on here. Our reactive function returns a proxy into our product object. We have our total, our effect. When we try to get price, it will run track, product, price. And inside the target map, it'll create a new mapping for product, with the value being a new depths map. And this will map the price property to a new dep, which is a set of effects, adding our total effect to the set. Then we'll call product.quantity, which is another GET request, which we'll call track product quantity. This will access the dep map for our product and map our quantity product to a new dep set with our effect. Then we'll print out our total to the console, which is 10. Then we'll set quantity equal to 3, which we'll call trigger product quantity, which then runs the stored effect. Then we run console log total, and it comes out to 15, and we are now reactive. Pretty awesome how it all fits together, right? And knowing that this is what it looks like in Vue3. In the next lesson, we'll do one little code optimization here to make it look even more like Vue3, and then we'll dive right into the source code. In the previous lesson, at the bottom of our code, this is what things currently look like. If we add another get, for example, product.quantity, with our current code, track will get called, and it'll go through the target map and the dep to make sure that the current effect is being recorded. This is not what we want to happen. We should only be calling track when we're inside of an effect. So we need to change our code. To do this, we're going to introduce an active effect variable. That's the active effect that's currently running. And this is how Vue3 solves this problem as well. Then there's the rest of our code. And finally, we'll declare a function called effect, which takes in an anonymous function. First, sets this as the active effect, then runs the active effect, and finally unsets the active effect. Then we'll use this function for our total. This now means we no longer need to call the effect since it's getting called when we send our function in. So let's remove that. Our code's a little cleaner, but now we need to update the track function to use this new active effect. So let's jump back into our track code. Here it is as we left it. We need to make two modifications to this code. First, we only want to run this code if there is a current active effect. Then when we add dependencies, we'll want to add the active effect. This is how we fix the issue, but before we run this code, let's make our test a little bit more advanced. We're going to add a sale price variable, which starts at 0. and a second effect, which takes the product price and calculates a new sale price. Then we'll log out what the total should be and what the sale price should be. It's kind of like I'm writing a test. Then after we change the quantity, we'll log what the total should be and what the sale price should be. Then we'll change the sale price. And finally, we'll print out the updated total and also the updated sale price. Let's walk through this code execution step by step. So when we get to this console line, it's going to print out before updated total 10, 10, should be 4.5, everything looks good. Then we update quantity, that's going to rerun the total. Then it prints out the updated total, sale price is still the same. When we set the price though, that should run both the effects. And when we print out the values, we see that total is now 30 and sale price is now 9. Our code is working, and now track is only going to be run when we have an active effect. When I was writing up this test code, I realized it didn't make complete sense. Why didn't I make the total based on the sale price? If I would have done this, things would have stopped working. Because in this case, when sale price is set, I'd need to rerun the total. And that wouldn't happen because sale price isn't reactive. So how might we implement that? If you're familiar with a composition API, then you're probably thinking what I'm thinking, which is this is a great use for a ref. A ref takes an inner value and returns a reactive and mutable ref object. The ref object has a single property .value that points to the inner value. And if you're thinking it seems like he copy-pasted that right out of the documentation, you'd be right, but I just wanted to get it right. Since ref uses .value, I need to change our effects to use saleprice.value. So good so far, but now we need to think about how to define ref. There's two ways to do it. First, we could simply use reactive. A ref function would take an initial value, and we simply set the value key equal to initial value. This works for this example, but it's not how Vue3 does it, so let's look at that solution. In order to understand how Vue3 implements ref, we all need to understand what object accessors are, also sometimes referred to as computed properties. Now, these aren't Vue computed properties, these are JavaScript computed properties. You'll see what I mean in a second. Before we implement ref, let's take a look at a simple example. Here you can see I have our user with first name and last name. Object accessors are functions that get or set a value. So here we can declare getFullName, which returns a string that combines the first name and last name. Then we'll declare a setter called fullName, which takes a value and splits it into two different strings, setting the first name and last name. Finally, we'll print out the full name, set it, and then print it out again. In the console, I would see name is Gregg Pollack, and then it would get set, and I would see name is Adam Jar. This is properly using the getter and setter for full name. Now, how could we use object accessors to define ref? Well, first we define an object with a getter called value. This calls our track function with the object we're creating, R, and value as a key, and then returns the raw value. Our setter takes a new value, sets that equal to raw, and then calls trigger. We then just return the object. That's all there is to it, and if you look in the Vue source code, which we're going to do together in a further lesson, you would see that's how Vue3 does it. Obviously, it has a little bit more complexity, but that's the gist of it. Now let's see if our ref works. When we set the quantity equal to 3, our total is going to be different because we're using the sale price. Then when we change the price, again, our total should get updated. Let's walk through this step by step. First, we have our updated total. Looks good. We set the quantity. That's simply going to call our total like before. And that should get updated using the sale price, as it does with 13.5. Then, when we update the price, this will call our sale price effect to get rerun. And then, since sale price gets updated, that will trigger our total effect to get rerun. Finally, we print out the new total. And sure enough, both total and sale price get updated. If you want to play with any of the code that you've been seeing in the last 3 lessons, I posted a GitHub repo that has each of them, because obviously I really am running this. I'm not just making up that it works and putting it in my slides. So you can also run this stuff, and then stay tuned for the next lesson where we're going to be diving into the Vue3 source code and finding where it all lives. Here's our code as we've left it, now using a reactive reference. But if you're familiar with Vue3's Reactivity API, which if you haven't taken that course, you might want to go and do that, you might be looking at this code now and wondering, wait a second, why am I not using computed properties for both sale price and total? This is a good opportunity to do that. So what would that look like if we did? We would just send our anonymous functions into a computed function, returning the value, like so. But then, since we're building our reactivity from scratch, how would we define this computed method? And computed properties or computed values are reactive, kind of like a ref. So how would we create this? First, we'll define a computed function which receives a parameter we're going to call getter, because it gets a value. Then thinking about this, writing pseudocode, we're going to create a reactive reference, we'll call it result. Then we'll run the getter inside an effect because we need to listen for reactive values, and that will set the result.value, and then we'll return the result. Okay, this time with code. First, we'll create a reactive reference. Then we'll wrap our getter inside an effect, setting the result.value. And lastly, we'll return the result. Further down in our file, we have our console log lines. These should output the same values as before. Well, let's run it. Sure enough, we get before updated total should be 10 equals 10, sale price is 4.5. After we update quantity, it changes the total, as it should. And after we update price, it changes the total and the sale price. Our computed properties are working as expected. Great. That was simple. Our simple reactivity code already has an advantage over Vue2's reactivity code. Because remember, in Vue 2, we were unable to add new reactive properties to a reactive object after creation. So if we did something like this, where we set a new property called name equal to shoes, and then run an effect, it will properly run that effect. But if we then change the name inside Vue 2, well, it's not going to run the effect again, because name is not reactive. Get and set hooks are added to individual properties with Vue 2. So to add new properties, you had to do something that looked like this. It was kind of ugly. However, our current code uses a proxy. This means new properties can get added and they're automatically reactive. So with our current code, when we create a new reactive value and we change it, it will properly print out product name is now shoes and then product name is now socks. So with Vue3, since we're using proxy-based reactivity, when we have a reactive object using the proxy, we can add properties, no problem. So we've been building our own reactivity engine, and it's so similar to what Vue3 uses, we might be able to simply insert the Vue3 source with our code and see if it works. But how would we do that? Well, we could check out the latest Vue.next code, which at the time I'm recording is alpha 5. We'll then install dependencies for it by running yarn install. We'll build and package just the reactivity source by running yarn build reactivity. This will put a couple files in the dist directory, but the one we want is reactivity.cjs, which stands for common.js. We'll move this into our example directory. We'll then include this common.js library at the top of our file, like so. Now our code looks something like this. We create our reactive object. We have two different computed properties, same syntax. And then we have our console log lines. Only difference here is that I've removed our reactivity code, and instead we're requiring Vue3's reactivity library. And this code works as expected. And you're welcome to try this out on your own. Download this source, run it with Node. Also with Vue3, I wanted to test to make sure I could add a new reactive property and use effect like this. Sure enough, it prints out product name is now shoes and product name is now socks. If you want to run this code yourself, you can download the Vue source, compile it, download my example code, and run node 8 Vue Reactivity. Perhaps you might be getting curious about the Vue3 Reactivity source code itself. I know I was at this point. And if we took a look inside of the packages reactivity source directory, we'd find a few TypeScript files, which you should be able to read through just with your JavaScript knowledge, even if you don't recognize some of the TypeScript syntax. It's mostly just JavaScript. First, there's the effect.ts file. Inside here is where it defines effect, track, and trigger. Then there's the basehandlers.ts file. This defines our proxy handlers, get and set, which call track and trigger. Then there's reactive.ts. This defines our reactive syntax, which creates an ES6 proxy using our get and set proxy handlers. Then we have ref.ts, which defines reactive reference using object accessors, just like we did, which call track and trigger. And finally, there's computed.ts, which defines computed a little differently than we did using object accessors, but it uses effect and it also returns a ref-like object. If you're feeling adventurous and maybe a little bit curious, you might want to start reading through the source code yourself. And in the next 2 lessons, I've got a treat for you. I sat down with Evan Yu himself, asked him a bunch of questions about how he implemented the Reactivity API, and even had him walk through some of the code. So, stay tuned for that. So it's after VueConf US, and Evan was nice enough to spend some time with us, and we just recorded his deep dive, which will be another course on Vue Mastery. But I wanted to ask him some questions about specifically the reactivity, some that maybe you were wondering about as well. So first off, on Vue 2, we would call depend to save code and notify to run the code that was saved. But in Vue 3, we're calling track and trigger. Can you tell us a little more about why that is?
Well, fundamentally, they're still doing the same thing. The big difference is when you name them depend and notify are like verbs that is related to an owner. And that owner is a dependency. A dependency instance. So you say a dependency instance is being depended upon, or it is notifying its subscribers. Whereas in Vue 3, we changed the implementation of the dependency a bit. So technically, there's no longer a dependency class. And the logic inside depend and notify are now extracted into just 2 standalone functions. So when you call track and trigger, they're more like tracking something instead of something being dependent on. Right? It's really just kind of like a verb change, like from A.B to just B calling A.
Nice. And then you kind of just mentioned this, where in Vue 2 we had a dep or dependency class, and in Vue 3 we just have a set. And why this change?
So again, in Vue 2, having a dep class kind of made it easier to sort of think about the dependency as an object with some behavior. But in Vue 3, we noticed, also kind of due to the way how the implementation was changed, we realized that if we look at the code here, in fact, the old dep class contains 3 things: the subscriber set, the depend function, and the notify function. Now, if we extract depend and notify into track and trigger, which are now 2 standalone functions, then the class itself really is only left with a set. And at that point, it just doesn't make sense to have an object class wrapper for this set itself. So we can just make it directly a set instead of having an object to wrap it. So it's really more a implementation specific detail. Like, we're just simplifying it for performance reasons. Like, if we don't have to worry about performance at all, we would probably still make dep a class. But at this point, we just realize, like, from a pure performance perspective, the class is really no longer necessary.
That makes sense. And then the thing that I found frustrating is, if you do take depend and notify out of there, and all that dep is a set, why don't you call it what it is, which is effects?
Yeah, we tried that, but then when the name is used in other contexts where you have to actually deal with so there are other places where you have to call something effects as well. So that kind of creates a very confusing conflict. But conceptually, you can still think of it as a dep. So I remember you actually raised a pull request trying to change that name.
Yeah.
Right. So I was reviewing it and I realized, okay, this is confusing because the pull request actually, after the pull request, you will find places where in the same function you have something else that's also kind of like XXX effects, and then you have these deps, which is also effects, but they actually mean different things. So kind of put it this way, like the concept of an effect is kind of already used by something else. So yeah,
makes sense. And then this sort of diagram of target map, depth map, dep. Anything you want to mention about like how you ended up with this solution for storing effects?
Okay. Yeah. So in Vue 2, when we were using the ES5 getter and setter conversions, when you iterate through the keys on an object, and with the for each, you naturally have a little closure to store the associated depth for that property. It was pretty natural, so you didn't have to rely on something like this. But in Vue3, we're using proxies, and the proxy handler, it receives the target and the key directly. And you don't really get a closure for every property to store the associated dependency in.
Right. So you have to have something else.
Yeah, so we need to, essentially what we need is a way to, given a target object and a key on that object, how do we like manage to always locate the same dependency instance? So the only way to do that is to put them into two level of nested maps.
Okay, and I assume the name target map comes from proxy having like the base handler targets.
Yes.
Okay. So when we went in the course, when we defined refs, I realized that like, oh, you can define refs by just sending it to reactive, or we can use it the way I found it in the source code, which is using the object accessor. So I thought, why the different implementation?
So the first thing is a ref, by definition, should only expose a single property, that is value itself, right? But if you use reactive, technically you can attach new properties to it, and that kind of defeats the purpose of a ref. So ref should only serve the purpose of wrapping an inner value and should not be treated as a generic reactive object. The other thing is we also have like isRef check. The returned ref object actually has some special thing so that we know it is actually a ref instead of a reactive object. And that's kind of necessary in a lot of situations. And finally, there's also a performance concern here because reactive does a lot more than just what we are doing in the ref. For example, when you try to create a reactive object, we have to check whether it already has a corresponding reactive copy of it. We have to check, for example, if it has a read-only copy of it. Like there's a lot of extra work you have to go through when you're creating a reactive object, whereas if we are using an object literal here to create the ref, it's just much more performant.
Okay, thanks. So using Reflect and Proxy in Vue3 allows us to add properties later, and I saw that in the course. But what other benefits does it give us?
One interesting benefit is when you use proxies, the so-called reactive conversion can be made lazy. So in Vue 2, when we do the conversion, we have to be eager because when you are iterate past an object to Vue 2's reactive equivalent, we have to iterate through all the keys and convert them on the spot so that later on when they're accessed, they're already converted. However, with Vue 3, the proxy, when you call reactive on an object, all we're doing is returning a proxy object. The nested objects are only converted as needed when you access them.
Oh, wow.
Yeah, so that's like kind of lazy by default. Now, one obvious benefit of this is if your application has a huge list of objects, But with pagination, you are only rendering maybe the first 10 of them on the page.
Mm-hmm.
Then only the first 10 of these objects will have to go through the reactive conversion.
Oh, wow.
Yeah, so that saves a lot of time in terms of booting up your application.
Nice. Thank you for watching this quick Q&A with Evan Yu, the creator of Vue. In the next video, Evan and I are going to walk through the Vue3 Reactivity source code, so you'll want to stay tuned for that. So we're about to jump into the Vue3 source code. I thought it'd be amazing if you could walk us through like some of the basic reactive stuff, because we've been coding it on our own, but I haven't taken the users through the Vue source code because there's so much more to it. It would be amazing just to walk through just a little bit, like maybe the get and set methods and base handler, just to see like about all the things you have to worry about.
Okay.
So maybe let's start there, and then maybe we'll go into the track and trigger methods.
Okay, so we are with the base handlers. There is a lot.
There's a lot.
There is
Should we skip to get or something?
Yeah,
or,
let's just go directly to the get.
Or create getter.
So yeah, create a getter has a read-only version and a shallow version. A lot of these are really internal or advanced usage.
Okay.
Read-only allows you to create a read-only reactive object that can be read and tracked, but you cannot mutate it.
Okay.
Shallow means when you set an object into another object as a nested property, it doesn't try to convert it into a reactive one.
Nice.
Yeah. So inside the get, the first thing we're here doing is there is something called array instrumentations. Essentially, the problem is when you have an array, reactive array, right? When you access something nested inside of it, what you get is a reactive version of the raw data inside of it.
Oh, wow.
Right? If you have something like const array equals reactive, maybe just an object, then you do AR0. Right? So this object is the reactive version of it. So here we are creating some sort of an identity problem. This is very rare. So this is like really, really edge cases. I don't know if we really should dig into it that much. But
Okay.
But like if you have an object like this.
You can give us the short explanation. It's okay.
Yeah. Right. So if you compare objects and reactive objects, it will be false. So this essentially, that's the case, right? The problem this creates is if you do index of object like this, this will be -1 if we didn't have this in place.
Okay.
Yeah, so this is only to handle this edge case.
Yeah. Okay, moving on.
Okay. Right, so that's array. And now we're just calling reflect get.
Yep.
And this, see a bunch of built-in symbols. So this is only to skip parts that we really shouldn't care about.
Okay.
So in ES6, there are a lot of like these internal symbols. For example, like iterable, symbol.iterable. If you are not familiar with these built-in symbols, you probably will have a hard time getting a hand of this. But essentially, the short version is we're just skipping any internal symbols that we should not care about.
Okay.
Yeah. And now we're handling the shallow part. So if it's shallow, we just return the object as is without converting it.
Okay.
And then this is about ref unwrapping. So when you nest a ref under a reactive object and you access it, it gets automatically unwrapped.
Oh, you're unwrapping.
So you're checking if this is the return value is a ref, and if it's a ref, we will just return it. And then now this is the actual code where it's a normal property.
Yeah.
So we will track the access and return it. Now, when we return it, we will have to convert it. So make sure to only convert it if it's actually an object. If it's not an object, we just return it as is. Okay. Only objects are trying to. We will attempt to convert the objects. Now, based on whether this is a read-only getter, if it's read-only, we return a read-only copy. Otherwise, we return normal reactive copy.
Okay.
Yeah. So that's the getter.
Great.
And the setter have the similar kind of read-only and shallow.
Yeah, that's
So this is really just checking if this is the user is attempting to mutate a read-only property. And if that's the case, we will warn it. And we get the old value. Here, this is really checking if we're setting a property that is in fact a ref.
Oh, then you just set the value.
Yeah, we set the value.
That makes sense.
Yeah. Now in shallow mode, we just set as is, regardless if it's reactive or not. And then we check whether the target previously had the key. If it previously had the key, then this is a set operation. But if it did not have a key previously, then this is an add operation.
Whoa, I'm baffled by what you just said. If what do you mean has the key? If it has, if the target has the key. Oh, I get it.
Yeah.
Like if it's an object that key exists, and if it doesn't exist, then we're actually trying to add.
Yeah.
Oh wow.
So there's different types of operations we can sort of track.
Oh my goodness.
Yeah. So this kind of information will actually be exposed in the debugger hooks, so that you can sort of have an idea of like what happened. Like, did you just add a property to my object?
What type calls the set handler when it's trying to add?
So the set handler is a proxy trap. So set handler, the set proxy trap will trigger for both add and set on the same object. Essentially, the proxy doesn't care because from the user's perspective, it's always object.foo equals something, right? So that's a set operation. But so from a proxy or the JavaScript engine's perspective, they are kind of the same thing at the proxy trap level, but internally we can still sort of figure out whether it's really an add or a set.
Okay.
So this information really is only for Vue to sort of optimize some of the behavior and also provide more information during debugging.
Okay.
Yeah.
Oh, wait. Add meaning like this doesn't exist yet?
Add, means this property previously did not exist.
Okay. I thought we were saying add, and I was thinking like subtraction and addition.
Oh, no,
like
no,
it was
no,
doing
no.
some weird sort of adding to number or something.
No.
Okay.
Yeah. So this is a new property addition.
Got it.
Essentially.
Okay, cool. All right.
So we trigger the effect by giving it the target, the key, the type, and a bunch of extra information.
Great. And what we didn't go through delete property. When does delete property get called?
When you call the delete using the delete keyword to delete a key.
Okay.
Yeah. So that was previously also not trackable in Vue2.
Okay. And then can we look through track and trigger?
Sure. Track.
This is, there we go. Okay.
So inside track.
Yeah. What's going on?
So obviously the first thing is we have some internal flags, conditions to check. Like in certain cases, you just shouldn't track at all. Active effect means because track will be called all the time. Like if the reactive object is just accessed without any currently running effect, then this still gets called, but the active effect will be undefined, and we just don't do anything.
Yeah, we've got that in our code too. That's great.
So this is essentially exactly the same thing we did previously. Now,
wait, hold on. Wait. Down here, I'm noticing you've got add active effect. Okay, so here's what's interesting. So we didn't cover this.
Yep.
That active effect has its own set of depths.
Yeah.
Talk about that.
This is a two-way relationship between the depth and the effect. So an effect can have multiple depths, and a depth can have multiple effects as subscribers. So it's a many-to-many relationship.
Oh, wow.
Yeah, so it's many-to-many, and we need to keep track of that only because we need to do the cleanup. And that's the thing we skipped during the code demo.
Yeah. You need to do the cleanup. So what does that mean? So when
the cleanup is done, let's just look for it. Cleanup. That's here. Let's run. I guess we should maybe go all the way through trigger first.
Okay.
Yeah. So when you trigger something, we go through the same depth map and depth thing, and there are some situations, for example, when a collection is cleared, you essentially have to trigger all the effects associated with it. And then there are some cases where we're mutating the length of an array. This is actually a recent addition. Just optimizes the case where array length is mutated. And then there are cases where set at delete. So here, at runners means, notice these effects, right? That's why we didn't rename them to effects. So this effect is a set of effects that eventually are associated with given these information, target, key. So for that key on this target, these are the associated effects that should be run. So we go through the depth map, and each depth is already a set of effects. So we're essentially adding these depth effects into the current effects we're collecting. Add. Yeah, so all of this really is just like, what we're doing is, given this target, given this key, what are the effects that should be rerun if this was changed?
And why are we adding, what's the add runners?
So add runners goes into here. Really is just taking a set and adding it to both of these sets based on whether the effect was computed or not. Now, we have two separate computed runners and normal effects. So the naming is a bit confusing, I guess. These are essentially internal effects, like component render effects.
Okay.
And these are userland effects, like computed properties, watchers. That's pretty much it. So we want to make sure that these two are run in separate. So you don't have like one component updates, then another computed property update, then another component update. So you want to have all these DOM touching effects to be run together, then all the user, computed, and watchers run together.
Which one's first?
Always component first by default.
Okay.
Yeah, but the watchers actually have an option that allows you to configure it. You can opt to let your watchers run before components are updated, but you probably only want to do that when you really know what you're doing. Yeah.
Okay. So that's the runners. We were back in trigger.
Essentially, we're just putting this, depending on what type it is, into these two buckets.
Okay, and then what happens?
And now, after all the runners are added, we end up with both of these. Actually, computer runners run before these effects. I was wrong.
I would think that would make sense because you would want to calculate all the user values before you trigger a re-render.
Yeah, that's true. That is true. Yeah. So we're just taking both of sets and for each to ask them to run. So when we run, we do something called schedule run.
Okay.
When we schedule the run, we pass them a lot of information. So let's go into schedule run. A lot of these information are really used only in the debugger event. So the debugger event will contain information about the effect, the target, the key, and the type. and it will call the correct debugger information when necessary. And an effect can have in its options, it will have something called a scheduler.
Okay.
So if it has no scheduler, then this is a synchronous effect. That is to say, anytime you mutate a property, the effect immediately reruns again. This is inefficient because if you mutate two properties together, the effect will run twice. When in fact, because the two mutations are synchronously one after another, you can wait until both mutations are done and then just run it once. So that requires some sort of deferring. And that can be done with a micro task. That is pretty much what next tick is doing. So by default, this scheduler, if this is a component update, then this scheduler will be next tick, essentially. Well, actually, it's not next tick. It's queue job. So we're going to
Oh my gosh.
not compiler, runtime core source. There's a file called scheduler. It manages the update order of components to make sure they are always updated in the correct order, and also handles the deferring. So that's schedule run, right? So I think one of the more relevant parts for average developers would be these like debugging hooks, which can be really useful. So maybe we can show a demo of that.
I'd love to see that.
Yeah. So if we go into okay, cool. So I'm going to take watch effect from Vue and say watch effect So now this is a very basic usage of this. So this can take an options object and say like on track. Typically what I would do is just do debugger. And if you run this with the DevTools open, it'll just pause here. Inside here, you'll be able to inspect this debugger event, and you can see the target. That's the state object that we got. And type is get, key is count. So this means this effect has tracked state.count as a dependency, and the dependency type is get. So it accessed state.count.
Nice.
So now we also have a corresponding untriggered. Now this one will be called when it's triggered. And similarly, it will give you this target. So now you know the reason my effect just rerun is because it's this object, its count was set to a new value, and it contains like new value, old value like this.
Wow, so you can really trace how your watcher got rerun, or even how a render on your component got retriggered.
Exactly. So the component has the same hooks. So in v3, the component, when you use the options API, they're called render tracked and render triggered. So they're exactly the same. They will receive the same debugger event. So you can use these to understand why a component is re-rendering and whether it has tracked something it should not have tracked. Now, this is more, I use this when I find something wrong with the Vue3 implementation internally a lot. But for users, this will probably be more useful because sometimes you'll be like, why is this component re-rendering? I don't understand why. So you can just use this hook and you understand, oh, this object, this property, it was mutated.
Nice.
Yeah. So it gives you a much better understanding of why everything is happening under the hood. Right?
Nice.
Inside composition API, you have the equivalent on-render triggered hook that you can use here.
Mm-hmm. Great.
Yeah, so that's it.
Awesome.
Reactivity debugging.
How fun is that?
Yeah.
All right. Well, thanks for taking your time.
Yeah, you're welcome.
Congratulations, you made it all the way through the Vue3 Reactivity course here on Vue Mastery. So where do you go next? Well, if you haven't done the Vue3 Essentials course yet, you'll want to do that to get familiar with the composition API. Otherwise, if you're watching this, depending on when you're watching this, the Vue3 Deep Dive with Evan Yu might be out. Check out that course because we go even deeper into how Vue is created with the creator himself.